A single-line diagram, or SLD, is a simplified schematic representation of an electrical system. It shows how electrical power flows from the source to the loads using single lines and standard graphic symbols. SLDs are especially important in solar and battery systems, helping electricians and designers visualize connections between key components such as PV arrays, inverters, batteries, switchboards, and protection devices. SLDs are commonly used during equipment installation, maintenance, system commissioning, and fault finding. They support electrical safety, reduce downtime, and improve system reliability. In many cases, SLDs are part of the documentation required for compliance with standards such as AS/NZS 5033 or 4777, or for grid connection applications with the DNSP. Unlike physical layout drawings, SLDs do not represent the actual size or placement of equipment. Instead, they focus on function and electrical flow. A single line can represent multiple conductors, and symbols indicate the type of equipment or protection device. Diagrams generally begin at the top of the page with the power source and flow downward toward the loads. SLDs use standardized schematic symbols. It's important to become familiar with these so that key system components can be identified at a glance. The orientation, size, or line width of a symbol does not change its meaning, though it may be adjusted for clarity or emphasis. Where needed, dash-dotted boxes can group symbols to show that they belong to the same physical unit or location, such as an integrated inverter battery system with integrated isolators, or the PV array and disconnectors being located on a roof. To create an SLD, start by connecting the major components using single lines. Include the grid connection, if applicable, main switchboard, circuit breakers, isolators, inverters, batteries, PV arrays, and their respective disconnectors. Then, add equipment details such as names, quantities, cable sizes, and current or voltage ratings. The amount of detail included depends on the diagram's purpose, for example, design documentation, installation guide, or compliance submission. It's also helpful to distinguish an SLD from other diagrams. Wiring diagrams show individual conductors and terminations, while layout diagrams depict the physical arrangement of equipment. SLDs should be updated regularly, ideally every 5 years or after any system changes like upgrades, configurations, or protection adjustments. When used correctly, they are an essential tool for safety, communication, and troubleshooting in any electrical or renewable energy installation.